research.
No, then we'll say. So I have experience in the different fields. So I started my journey first initially with the teaching the intermediate and AIEEE and MCET classes from 2000 to 2007. And after that, I feel okay, it's maybe I feel a little bored. And then I thought, okay, maybe after PhD, once it's completed, then I thought I will join in the industry. Then 2006, December 9th, I joined in the Hedro Pharma in the Balnagar AR&D, in the AR&D department. I joined as the analytical chemist. That time when I joined, I am the first PhD student who entered into the industry because I don't know about the analytical chemistry. Then I worked there in the 1 year. Then after that, actually, I got the postdoc opportunity, and it's Taiwan. So there I worked almost more than 6 years, 2 months. And then I almost there, my position is almost a permanent position. And then I got the job in the Usman University in 2013. I moved here, joined as the assistant professor. Currently, I am the associate professor. So this is about the because I never diverted other than chemistry. I am in the chemistry only always. So there also I worked in the mass spectrometry, but it's whatever I am speaking, it's a little bit different because there I worked in the complete on the research direction. There I can show the 4-5 slides in the last presentation. I can show what we can do with the mass spectrometry, what wonders we can do with the mass spectrometry. So that's my topic is the advanced mass spectrometry. It's a little advanced. That is, those who are working in the industry, for them is because the in the basic mass spectrometry, advanced mass spectrometry is different. So earlier the mass spectrometry means so you are interacting with the high energy electron beam, and any molecule or sample with the high energy electron beam. So the molecule or sample. So we use high energy, approximately 70 electron volts, and it it loses one electron and produces the molecular ion. That we call it as a molecular ion. That is radical cation. We call it as the molecular ion. So mostly if you study in your MSc, the first year the basics, this one. But here my focus is the more than the EA, because the EA is the basic. This is like a for mass spectrometry, this is starting point. But now the industries are not current. They are not specific. Mostly they are not using the EA. Only small molecule HR only. EA is the source. But more now how many are from the industry? No industry. Okay. Oh, it's a good number from the industry. How many are teachers? Teaching profession. So the industry people, maybe if you are working in the AR&D department, maybe they can more connect with this kind of. Maybe you can connect with these techniques. Okay. So let's start with the. I'm going to discuss with the. So what is the what the mass spectrometry will do, and what are the basic principle of the mass spectrometry, and what are the block diagram. Based on the block diagram only, entire you can decide the how many types of mass spectrometers are there, and various mass spectrometry, advanced mass spectrometry technique like GCMS, LCMS, tandem mass spectrometry, and multitude of MS, and few applications related to the mass spectrometry. And it's kind of interactive session. Maybe you can ask anytime in the question if you have any doubt or anything, you can ask. I'm not going to much inside deeper, so I'm going to give a fundamental only. In the last 3-4 slides, I will give about the where we can use this mass spectrometry, particularly in the research area, research field. Otherwise, other applications are known to everyone. Every field they are using the this mass spectrometry techniques, including forensic science. You might have heard some fingerprint approach. That is, it's from the mass spectrometry. They see the protein fingerprinting, like MALDI mass spectrometer. They mostly they use the forensic science. And if match with some crime is happening, so how they will compare so they see the DNA fingerprinting of the DNA fingerprinting of whoever, and they match with that one and they confirm that he only done that crime. So here we discuss about the it's somewhat the history and development about the mass spectrometry. Almost first it started with the 1899, and later most of the inventions are up to the 2001. Later also they have developed, but the only modifications I have done. And these are the somewhat history about the developments related to the mass spectrometer. I'm not going to read out, and maybe in this pen and there somebody has received the Kochi Tanaka, and when they received the Nobel Prize, that also I will show. So the recent from the America, they use the mark-pick pen to identify the cancer in 10 seconds. So they actually they have where the cancer cell is there. If you keep that pen on that cancer cell, there is a water will be there, na? So it will that pen will suck the water. If it connect with the mass spectrometer, generally it gives some kind of signals. It's like we call it as a spectrum. Generally, what the main information what we are going to get it from the mass spectrometer, the main information we are going to get a molecular weight and molecular formula determination. So based on that, the cell is the normal or it is the cancerous. That information we are going to get it from the. So this is the recent work from the University of Texas they have done. So they produces some kind of chemical fingerprint. So then the doctors will decide whether the cell is the normal cell line or it's a cancer cell line. So they can detect the cancer in the 10 seconds. This is a recent development in this mass spectrometry technique. So about what the information used to get it from the mass spectrometry is the mainly molecular. It's a powerful tool to determine the molecular weight of a compound. So you know the molecular weight, yes? Like for example, if you see any kind of compound, like for example, H2O. So hydrogen the atomic weight, 2 hydrogens, 2 plus oxygen is the 16. Then total molecular weight of compound is the 18 it's a simple molecule. But there is a complex molecule, there are the proteins, peptide, whose molecular weights is sometimes thousands, sometimes lakhs. So therefore, the information, basic information, what we are going to get it from this technique is the molecular weight determination. And also identify the unknown compounds. For example, this is a PowerPoint presenter. So we don't know what type of compounds are there here. It's a polymer, maybe PVC, or what type of compound. Just I am taking this is the one of the example. So to identify this, what are the compounds are there, and also to quantify. Quantify, for example, so this some X has some material has maybe compound like C6H12O6. How much that's identification of that compound and quantification. What type of compound is there? How much of compound that is present in that unknown sample? Like for example, most of them they had like in the Corona time, Anandaya medicine. Yes, this is a very famous. They have that time, but actually why it is not succeeded? because we didn't do any kind of analysis. We don't know what type of compound is there. So what is that compound, that we don't know. And how much is that compound is there, we don't know. So what the mass spectrometry, what is the this advanced tools, what they do, it identifies the what type of compounds are there, how much of those compounds are present in this like Anandaya, like maybe now more majority we are taking some kind of plant products. For example, if you see this one, what we will do, మనకు అరగలేదనుకో కొంచెం వాము తినడము లేకపోతే జీలకర్ర. But actually, so what type of compounds are there? We don't know. Really, we don't know about the chemical compound. But if you go for a English medicine or whatever that, so they write aspirin, acetyl salicylic acid. So they write the chemical name and this compound is there. This compound will work for the headache or head pain. But this kind of techniques are particularly used for the identification of the unknown compound and quantification. So that is the one of the advantage for this technique. And structural elucidation of the particularly small molecules to the large molecule. Small molecules means like some kind of aspirin, like amino acid. Glycine is a small molecule. If, for example, alanine is a small molecule, if amino acid, if 5-6 alanines combined, one glycine, alanine, amino acid combined give peptides. Peptides combined give proteins. Proteins gives like again enzymes or this. So for you can determine the small molecule from alanine or glycine structural elucidation to the peptides, then the proteins and enzymes. So this is the one of the, and what the mass spectrometry will do with this, it will do. And the advantage of this technique is it requires the compound picogram to the nanogram. And if the compound is very, very, very less, so that is enough to identify, so what is that compound. Now maybe in the industry, maybe use the very, very less compound. They inject it and they identify that one. And also these are the some and also particularly in the bioanalytical research, identification of proteins, peptides, so enzymes, what type of proteins are there. So particularly proteomics and genomics. So it is one of the most important and essential technique, and particularly those who are working in the biotechnology, biochemistry, and this will come under the bioanalytical chemistry in the particularly in the industry. And also the not only the structural identification, but you can also determine with the non-covalent interactions, protein peptides, sequencing, DNA sequencing, and protein folding and drug discovery and other applications. We can use this kind of technique, mass spectrometry. So this is also the almost the same. What it can do is determine the accurate mass of the elements and structure and analysis of the organic compounds and quantitative analysis of the inorganic compounds, analysis of the pollutants in the air, water, and whatnot. We have the how to say it. This technique, those who are working in the industry, it's very essential. Particularly those who are working in the either bioanalytical industry or pharmaceutical industry or any industry, this is most important or most essential technique. And also the clinical studies and analysis of the explosives and banned substances, drug testing in the sports. These are all the various applications of the mass spectrometric technique. And these are these guys who received the Nobel Prize, and Penn and Kochi Tanaka, and along with the Uttrich. And 50% Nobel Prize they have given to the NMR, 50% they have given to the and one quarter, and half is for the NMR, half is for the mass spectrometry, and particularly for identifying the ESI, electrospray ionization technique, and particularly for the biomolecule characterization. They received the Nobel Prize in the 2002. And how does the mass spectrometry works? So the basic components of the mass spectrometry are the first you require the sample. You require a sample. There are the three important parameters. One is the ion source, mass analyzer, and detector, or you can get the final mass one. So what the ion source it will do? Ion source, it makes the ions. So what is ion? What is ion? A charged species. It's like maybe like for example, positive charged ions and negative charged ions. Okay? Plus unte, then we consider as a positive charged ion, and minus unte negative charged ions. Mass spectrum, what the ion source will do? Ion source, it makes the ions. It makes the ions. So second part of the mass spectrometry is the mass analyzer. So what the mass analyzer will do? It separates the ions. For example, ion source, it makes the ions, and the mass analyzer, it separates the ions, and detector, it detects the ions. Finally, you get the mass spectrum. These are only three important main. If you take any mass spectrometer, one is the ion source, second one is the mass analyzer, third one is the detector. Ion source, it makes the ions. Mass analyzer, separates the ions, and detector, detects the ions. For example, let us take a like human body. We have the like head is one ion, two hands are one ion, two legs are one ion, one stomach part is. So what the ion source, it makes the ions. So like head plus, two hands plus plus. And what the mass analyzer do, it separates it. So first they send it to the head, you will get the mass of the head. Hands, mass, then leg. So detector, it detects the ion. This is the molecular weight of head. This is the molecular weight of hand. This is the molecular. So these are the three important things in the mass spectrometer. So mostly, if you see the block diagram, first one, you from this you can entire advanced mass spectrometry you can understand. One is the inlet. First one is the inlet. So inlet means how your sample is, you are entering into, you are sending the sample into the mass spectrometer. If you use, I think you might have heard HPLC, high performance liquid chromatography, gas chromatography, capillary electrophoresis, sample plate, or flow injection, or you can directly inject or solid phase inject. Various inlet methods are there. So whatever the sample, for example, let us consider we have a mixture of A, B, C, D in a one sample. A compound B, compound C, compound D. And what the like chromatographic techniques, what they will do? So it separates into the A, separates into the B, separates into the C, separates into the D. Chromatography, HPLC, for example, if the volatile compounds means you use gas chromatography. If non-volatile means you use HPLC. So depending on so this is the source, because we have separated the compounds like by using HPLC or gas chromatography, and then once the separated compound, then you are entering, the compounds are entering into the mass spectrometer. So first part is the ion source. So what the ion source will do? It makes the ions. So some making of ions, we have the different kind of, based on the how you are making the ions, we have the various types of the mass spectrometers. One is the EI mass spectrometer. For example, how you are making. For example, if you are making, if you use high energy electron beam, like approximately 70 electron volts. If you hit the sample with the high energy electron beam, approximately 70 electron volts. So the molecule loses one electron and produces a radical cation. This radical cation is known as the molecular ion. If you make the ions, if you use the high energy electron beam, then we call it as the EI mass spectrometer. How we were making EI mass spectrometer, electron impact mass spectrometer, chemical ionization mass spectrometer, CI mass spectrometer, ESI, electrospray ionization mass spectrometer, MALDI of matrix assisted laser desorption ionization mass spectrometer, and FAB fast atom bombardment mass spectrometer, SIMS secondary ion mass spectrometer, and how you are making the ions. So EI, you are hitting with the high energy electron beam. For example, let us take a MALDI. So MALDI, you will not hit. What you will do in the MALDI, you take the sample, you mix with the matrix, that is the name itself, matrix assisted laser desorption ionization mass spectrometry. You mix with the matrix, then you use some laser energy to hit the matrix absorbs the laser energy, then it transfers to the sample. And for example, if you hit one deba kottinu anukonam, so direct kottedi EA, madhyalo addam untadi matrix, and you are not hitting directly. So and based on the how you are making the ions, we have the various types of the mass spectrometer, EI mass spectrometer, CI mass spectrometer, ESI mass spectrometer, MALDI of MS, and Fab MS, fast atom bombardment, based on the ion source and how we were making the ions. So depending on the compound, we are going to make the ions. And then second part of this one is the mass analyzer. So mass analyzer, what is the role of mass analyzer? Separate the ions. This separation also, let us take a time of flight or quadrupole, ion trap, magnetic sector, or FTMS. There are various mass analyzers. Like let us take a one, I will explain, or one or two. So it's a quadrupole. Quadrupole means 4 poles. This is one pole, here one pole, left one pole, and right one pole. And once the ions are entering to this quadrupole, generally there are 2 poles and opposite poles. It has one charge. For example, let us say top pole and bottom pole is positive, left pole and right pole will be the negative. Once the ions are entering to this one, always negative ion will go towards the positive pole. Positive ion goes towards the negative pole. So they never mix up. Initially itself, these ions are going to be separated. Positive ion always negative, negative ion always positive pole. And the thing is, these whatever the charges, this pole charge is never fixed. Always like top and bottom is the positive, left and right is the negative. Immediately in the fraction of second, top will become the negative, left and right will become the positive. So therefore, ion always move in a circular motion. So based on the mass to charge ratio, these ions are going to be, it's a quadrupole, and each mass analyzer has their unique nature, and ultimately, so these ions are ultimately the mass analyzer role is the separates the ions. So for example, if the ESI coupled with the quadrupole, then we call it as a ESI quadrupole mass spectrometer. For example, MALDI coupled with the MALDI TOF, time of flight mass spectrometer. For example, EI coupled with the time of flight or ion trap, EI coupled with the time, EI electron impact TOF mass spectrometer. That's why we industry triple quadrupole. Latest one is the now not the single quadrupole. All are tandem mass spectrometer, triple quadrupole, and TOF. Triple time of flight mass spectrometers, and ion trap and quadrupole mass spectrometers. Maybe I don't know, for example, those who are working in the pharma, and that also I will show some pictures which are from the industry, which what the kind of instruments are used in the industry. So ultimately, the mass analyzer role is it separates the ions and the detector. So what the detector role is, the detector. We have the various detectors, electron multiplier or micro channel plate. So these are the detectors. The important thing is always the entire instrument is under the high vacuum. Why high vacuum is required? So mass is the highly sensitive instrument. Even it can detect if it is air is there. So that mass also it can detect. So that's why always we entire the instrument is to be in the high vacuum. So generally this high vacuum it is going to be maintained by the turbomolecular pumps. So this one about the various types of the, like for example, if I give the abbreviation LC, ESI, TOF, quadrupole, MS, and that means liquid chromatography and HPLC coupled with the electrospray ionization. So liquid chromatography is the separation technique. Then ESI is the ionization technique, how it is making the ions. And then time of flight, it separates the ions. It's a mass analyzer. And another, what I am saying, quadrupole, another mass analyzer is there. If a mass spectrometer contains two or more mass analyzers, so those mass spectrometers, we call it as a tandem mass spectrometer. But current today's era and present 2026 is only tandem mass spectrometer in the industry. Every industry has the LC, MS, 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 or GC, MS, 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 small d of MS. So entire the industries, they have the tandem mass spectrum and not a single, means not a single mass analyzer. They are using two or more mass analyzers. So that means the required information, they require the more accurate information. And again, checking. So that's why majority of the industries has the only the tandem mass spectrometer or MSMS mass spectrometers. So these are about, for example, if you use the separation GC, gas chromatography, ionization EA, TOF, MS means gas chromatography, electron impact, time of flight, mass spectrometer. It's a spectrometer, not the spectroscopy. Metry, mass spectrometry. Metry means we use the instrument. Spectroscopy lo major we use the electromagnetic radiation. Here we are not using any kind of the electromagnetic radiation. What is electromagnetic radiation? Cosmic rays, gamma rays, X-rays, UV visible, IR, radio wave, microwave. These are the electromagnetic radiation. Here we don't use all the instruments. If you end with the metry means instrument, like potentiometry, conductometry, mass spectrometry. But IR spectroscopy, NMR spectroscopy, UV visible spectroscopy, because there we use the electromagnetic radiation, UV visible rays, NMR radio waves, X-rays, like that. Okay. So this what about the block diagram. And from this, we have the how many types of the mass spectrometers are available. So EA mass spectrometers, EA, FAB, ESI, MALDI. So these are all various types, but and various combination also. Based on they may change ion source, they may change maybe. So they can connect. For example, MALDI connect mostly, preferably connect with the time of flight. For example, ESI is suitable for time of flight, quadrupole, and ion trap. Particularly when it comes to the GC, coupled with the EA coupled with the quadrupole, preferable combinations. So these are the various types of the mass spectrometers. So these are the, if you see inside the mass spectrometer, these are the three components. So this is the gas chromatography, and from liquid sample from here we are going to inject. So this is the ion source solution where the ions is going to be formed. Maybe you can, for example, if you let us take a electron impact, we use high energy electron beam, or maybe the these are the, yeah, if you see this one in the ion source, what we are here we are using the high energy electron beam, approximately 70 electron volts. So what is going to be happening? M is the molecule, so it is losing one electron and forming a M with the one plus charge and one dot. If a dot is there, like we can consider as a, and if we lose the one electron, then we write it as positive charge. Another one electron is there, na? If a odd electron species, we call it as the free radical. We call it as a radical. Then the name of this one is the radical cation. This radical cation is known as the molecular ion. Generally, this molecular ion is unstable because you are hitting with the high energy, approximately 70 electron volts. But once you are hitting with the high energy, but to form the molecular ion only requires 12 electron volts, not 70 electron volts. So once it is forming, this radical cation unstable and produces the variety of the small pieces. So these ions, we call it as the fragment ions or daughter ions. So the process, we call it as the fragmentation. The entire process, we call it as the, and here the how the in the EI, how it is forming, we are using high energy electron beam to make the ions. For example, let us see the ESI, electro spray ionization. So in the spray, actually we are using the sample solution and along with the nitrogen gas at the tip of this capillary, applying the high voltage. So once your sample reach to the tip, and then the sample is undergoing the ionization, and like how it is ionization also, then it is converting into the bigger droplet. Bigger droplet has almost, here this droplet has 6 ions, and slowly when you pass the drying gas, like nitrogen only, so this bigger droplet slowly, like 6, it's converting into the 3, then 2, then single ions. This is how the electro spray, and you are applying some electrical energy approximately. So then how it is forming like a spray. Then this type of ionization, we call it as the electros, and each, like EI, it is forming one way, and electro spray, it is forming the ions in the different way. So then if you see this one, Moldy, how you are doing, this is a sample plate. You are mixing the sample with the matrix, like you are hitting with the laser, then the ions, the sample is mixed with the matrix, and then the laser flashes on the matrix, sample molecules ionized and produces the MH+. But all are the different type of ionization process. Yes, one is directly hitting with the high energy electron beam, and second is your sample is, you are sending into some capillary tube. At the tip of the capillary tube, you are applying some voltage, and another one is the mold. So these process, we call it as the ionization. Based on the ionization only, we have the various mass spectrometer. One is EI, CI, FAB, electrospray ionization, MALDI, and various mass spectra. So these are the different ionization: electron impact, chemical ionization, field desorption, fast atom bombardment, secondary ion mass spectrometer, and MALDI, matrix assisted laser desorption ionization, and electrospray ionization. These are the various ionization techniques. So then, so this what is going to be happened here is this one. Like ion source, it makes the ions. Then you see the next where it is entering to the mass analyzer. Here like quadrupole. So what the mass analyzer will do? It separates the ions based on their mass to charge ratio. Ion mass analyzer will do, it separates the ions based on their mass to charge ratio. We have the, I will use few, I will show the few example. So mass analyzer separates the ions based on their mass to charge ratio. So here the few mass analyzers, like these are the different types of mass analyzers. One is the magnetic sector, quadrupole mass analyzer, time of flight mass analyzer, ion trap mass analyzer, orbit trap mass analyzer, ion FTICR, ion cyclotron resonance mass analyzer. But all the ultimately the role of the mass analyzer is the, it separates the ion based on, but the, each mass analyzer, the function is the different. For example, let us take a quadrupole. Quadrupole mass analyzer, if you consider this room, so one, you see this two poles has the negative charge, these two poles has the positive charge. Once the ions are entering to this, in between the poles, always this negative poles will become again positive. This positive poles will become the negative. For example, let us see, we all are entered into the, this is our room. For example, I consider as the ladies is the negative, boys is the positive. Where we will go? For example, always girls will go to the, maybe above is the positive, means girls will go to the positive, boys will go to the negative, means from left side. And here automatically these ions are separated. Then automatically what it's never fixed, this poles. Again the positive poles will become the negative and negative poles will become the positive. So side in a boys, then it will come to the down or top. Girls, like always ions moves in a like a circular motion. So based on the like a running competition, we have to reach to the detector. So we have the different masses, nobody mass. Let us consider it. Our weight is the molecular weight. Running competition. So who will reach the detector means mostly depending on the small molecule will reach the detector first, then the medium, then the larger molecule like that. This is like quadrupole, and this is also the same quadrupole, like 4 poles. And this is the ion trap mass analyzer. It's like a trap. It's a small kind of small ball into the machine, trap into the. So this is the ion trap mass analyzer. Here almost the principle like quadrupole only. And this is a time of flight flying tube. Like here we apply the kinetic and Ke is equal to half m is current. The mass of the ion is inversely proportional to the velocity of the ion, because that actually some derivation is there, but I am not going to show. So these are the ultimately the role of the mass analyzer is the, it separates the ions based on their mass to charge ratio. Let us see. So there are the few videos. There is one is the quadrupole mass analyzer. How the it's a 3-dimensional 3D. You can see the, so how the quadrupole mass analyzer, and the entire process is there. Just let us see. So this is the ion source where the ions are going to be formed. So you are heating the sample and vaporizing. Then you see the you are hitting with the high energy electron beam. So the molecule it's break down into the pink and red and green and white ions. So then these ions are entering into the quadrupole mass analyzer. So you see the ions how they are moving. It's moving in the circular motion. Okay. So these ions reach to the detector. So first, which ion is green ion reaching the detector, the hitting with the detector there, and you are getting the first peak, like white ion, then red ion. You got the 3 peaks. So this is the valeric acid, the molecular, the compound is the valeric acid. Is the how, like this is the quadrupole, and it's separated, and how the separation is happened between the. Second one is the ion trap mass analyzer. You see the, it's a trap, like a small room. we all are, there is a collisions between the molecules. Which ion will come out first? Easy, it's a collision. Here we have the like different size, like pink ions are there, green there, blue and yellow. So then in the trap, this is the second kind of mass analyzer. It's a ion trap mass analyzer. So then once the first small molecule is come out first. So here you can see which is the small. I think yellow color is the small. Then it's a molecular weight is the 100, and then the blue, then the green, then the pink. So how, and because ultimately all the ions are separating, but the separation procedure is different. Whereas in the quadrupole, it's a moving. Whereas in the trap, it's like a small trap. So there is a collision with the trap, and then the ions are going to be separated. But the way of separation is different as compared to the quadrupole and as compared to the ion trap. And the third
Serum
one is
extracted from the blood samples, and small drops of the serum are spotted on a protein chip using a robotic system.
Yeah.
The chip
So
is then placed into a protein analysis device called a mass spectrometer. Inside the mass spectrometer, a laser hits the serum.
So then once you are hit with the sample plate, so then
ions
in the flying tube,
at different speeds.
Ions are
ions
traveling.
with smaller mass traveling faster than those with larger mass. Using the order in which the
like
ions
tube,
hit
it's
the
kind of
detector,
journey.
the spectrometer determines the sample's composition and creates a profile of the individual peptide components in the sample.
So if after seeing these three, but each mass analyzer is but ultimately the mass analyzer's role is separating the ions, but how it is separating, quadrupole one way, ion trap one way, and the time of flight is another way. But ultimately, the role of the mass analyzer is to separate the ions, and the role of the ion source is it makes the ions. But the way how these ions are going to be formed is the different. Based on that only we have the various mass spectrometer that we discussed. So one of the advanced mass spectrometry technique is the I will discuss 2, 3, 4. Just will give some brief idea. One is the advanced mass spectrometric technique is the gas chromatography coupled with the mass spectrometry. I think those who are working in the industry, they might know this, and particularly where the gas chromatography is useful, where like particularly volatile compounds. What are volatile compounds? Volatile compounds are there? Huh? So many n number of compounds, volatile compound. Like our perfumes are volatile compound. Our powder is volatile compound. In our Fair and Lovely has some volatile compounds. Everything has volatile compound. Yes? Yeah. Like if you see this one, all are like n number of. Like if you enter into the car, we never feel a bad smell because already the car doors are made with some kind of volatile compound inside. So whenever you go enter into the car, so you never feel some kind of other kind of, because there are the volatile compounds are there. Like odonil, if you go to bathroom, everything, and also if you take majority of like particularly naphthalene balls, yes. These are all the volatile. Like for example, if you when you are drinking tea, you will feel one kind of smell. When you are drinking coffee, the smell is different. Another coffee smell. So when you are heating it, so when you are boil the tea or coffee, then you can identify this is today she is making coffee and she is making tea. Or when you are cooking rice also will get some kind of food smell. So these are all come under the volatile. So in the pharma also, some tablets you won't feel good. It's difficult to take. The smell is different. Some compound, sulfur based, so so those compounds are called as the volatile compounds. And perfumes are different kinds of n number of perfumes. Every has unique smell. Deodorant. These are all majority of the cosmetics are the volatile compounds. So these kind of compounds, if you want to analyze those kind of compounds, so you require the gas chromatography coupled with the mass spectrometry. These are the two simple. So this is the one is the gas chromatography part. This part is the gas chromatography part. This part is the mass spectrometry, ultimately computer. What the gas chromatography will do, it separates the compounds. How the gas chromatography, there is any chromatography instrument, we have a mobile phase, stationary phase. Stationary phase means stable phase. Mobile phase means moving. Mobile canteens anara. For example, today a place lo unte breakfast. Now everybody is, if you go to any highway, Warangal highway, all are mobile canteen.
Yes.
So morning they will come, they will keep, and then afternoon they will go home. Yes. So this mobile phase means moving phase. Here in the chromatography, always like in gas chromatography, gas is the mobile phase. In the liquid chromatography, liquid is the mobile phase at HPLC. For example, in gas chromatography, mostly helium used as the carrier gas or acts as a mobile phase. Then you are going to inject the sample through injection port. Me doubt rounds. So how you will inject? You said gas chromatography. You have three kinds of samples. One is solids, liquids, gas. So you have to like maybe those who are working in there is a separate syringes are there. GC syringes are. So GC for those who are working in the gas chromatography, there is a separate gas chromatography vials there. So solid compound. Generally, you keep that solid compound, you apply the heat at the bottom, automatically the whatever the volatile compounds are there, that will come onto the top of that vial. Then you use the GC syringe, then you can inject. For example, solid. Liquid means you can directly inject it. Gas, you have to collect into the syringe, and then you can inject. So once you inject it in this injection port, generally they maintain approximately 250 degrees centigrade at the injection port. Automatically your compound is going to be vaporized. Then it's a journey in the column. So column is made with the silica and like some coating with the polyamide layer. That we're not going very deep into that. So like a journey, running competition in the like silica means like SiO2. And Telugulo em cheppandi? Iska. Beach lo running body.
Yes.
So who will reach the first? You have to run in the beach. So one will always, for example, let us consider here we have 40 members or 50 members. 50 members, nobody will reach into the same time. Yes, maybe difference may be seconds or minutes. So one will reach first, second will reach, for example, one will reach 3 minutes, second will reach maybe 2 minutes, 50 seconds, third will reach like the chromatography in the column, this gas compounds are going to be separated. Once the separated compound need to enter into this is the this is the gas chromatography part, this is the mass spectrometry part. Once the compounds are separated, need to enter into the mass spectrometry. Or how it will enter? So here the important is the always chromatography works at the atmospheric pressure. Mass always works at the first at the high vacuum. There is a pressure difference. It cannot enter into the mass spectrometer. Right? How it is going to enter? This is atmospheric pressure chromatography. This is the vacuum. If same pressure means maybe molecule directly. Simple. Atla. This cannot enter. Like for example, borlo neelu untaya. Pike attostune. You are applying some pressure and it is pressurizing. You are giving different horsepower pressure, then the water is from the bottom to the, it reached to the 5th floor, 10th floor, now almost 40, 50 floors buildings are there. It is reaching to the 50th floor or 40th floor. And so here also the same principle, because always chromatography, separated compound, it's difficult to enter into the mass spectrum. You require a called is the, you have to use some kind of coupling agents or some kind of interfaces. So in the GC, that those we call it as the interfacer. Thus we call it as the interface, because this will work at the atmosphere, this will work at the vacuum. Therefore, so the interface, by using the interface, like GC has the two different interfaces. One is direct coupling interface, another one is the open split interface. So by this way, these compounds are entered into the mass spectrometer. What the mass spectrometer will do? First, ion source region, here it makes the ions. Then the mass analyzer, it separates the ions, detector, detects the ion. Finally, you will get the, what is that compound, or the separated compound, molecular weight and the fragmentation pattern. So this is about the gas chromatography coupled with the mass spectrometry. The second one is the same picture only, but it's a computer that is drawn. And this we can see the some kind of, just I will show LCMS, I will not show. So how the...
This video is on GCMS based metabolomics. GCMS is the gas chromatography mass spectrometry, and metabolomics is the study of metabolites. It is non-volatile, rapid, simultaneous determination of the various plant metabolites. GC is used for the separation and MS is used for the detection of the compounds. By this way, hundreds of the samples can be identified in a single analysis. Introduction and principle.
So you see these two, in this only
This
we have
is
two
the
parts.
touch screen of the GC, and this hole is the GC
In
unit,
Managare,
contains the injector pore where we can inject our sample. And this is the MS unit, and this whole instrument is made by the Perklin Ilmer company. MS contains detector and analyzer. These both units are connected with the computer system where our result will be interpreted. GC contains the stationary phase, which is the 30 centimeter long tube whose column is packed with the substance of the high boiling point.
Like it's a capillary column.
And the compound of the mobile phase along with the sample leaves the column in order to volatility. Most volatile compounds leaves first, and mobile phase in a GCMS is the helium gas.
Helium is the mobile phase. If you go to the industry
MS
first questionnaire, they will ask,
MS
so what is the mobile phase?
contains EI source, that is electron ionization source, and the filament that produce electrons, which rotates and enters into the MS system. This instrument has the flame ionization detector, consists of hydrogen flame burning in the air. As substance leaves the column, it burns and produces the ion detected by the measuring electric conductivity of the flame, and values are fed to the computer. Separation of methanol and methylbenzene. Here first peak is of methanol, more volatile compound with retention time of 1 minute, and second peak is of methylbenzene, less volatile compound with retention time of 1.5 minute. Case study on Kauni rice variety.
This is one example, case study of the on rice variety.
Kauni variety is known for its antibiotic property. It is the medicinally important variety. Seeds are golden
this
yellow,
rice
brownish
now
black
is
in color.
available in the market.
Sample preparation.
Brown color rice and particularly
Weigh 1 gram of seed sample
variety
with the help of weighing balance.
What kind of is there?
Spread seed samples into the mortar and add the 2 ml of methanol.
They're grinding the sample with the methanol. Then after that, sonication.
Then grind the sample with the methanol for the extraction of total metabolites. After grinding, keep the sample and solvents mixture for the sonication for 110 minutes. After sonication, keep the vials at the 4 degrees Celsius for the 10 minutes for cooling.
This is the one example how they are doing. But depending on the compound, what
After
type
cooling,
of samples are to analyze so that based on that you have
centrifuge the samples
sample preparation
at
is the
5000 rpm for the 5 minutes.
important technique.
After centrifugation, transfer the supernatant to the fresh tube and used for GCMS analysis. GCMS analysis. For the analysis, we are using the TurboMass software.
Yeah, this is
Now
like how
activate
they
the
are going to
GCMS
do the
system.
analysis. So that's what about the GCMS, gas chromatography coupled with the mass spectrometry. And another one is the LCMS, liquid chromatography coupled with the mass spectrometry. This I will then I will not say the tandem and wall it off because already I think is time is running late. It's I think 2-3 hours is required the entire advance. Maybe next time we will explain the other two techniques. Just I will this one and then where the this mass spectrometry is applied for the research. So one is the next technique is the Maldita. One time I will explain maybe exclusively Maldita MS because that is most useful particularly for the forensic chemists and fingerprinting approach. So just that I will explain you later. And this is the second advanced mass spectrometry is the liquid chromatography coupled with the liquid chromatography means HPLC coupled with the mass spectrometry. So there the GC what we have done, the volatile compounds are going to be separated. Other than the volatile compound, there is the non-volatile compounds. So those are going to be separated with the help of the HPLC. Okay, once the compounds are separated, so and then say same like GC. This is the HPLC. Then they are entered into the mass spectrometer. Mass spectrometer, what is the first ion source region? It makes the ions. Mass analyzer, it separates the ions. And detector detect the ions, and then you get the finally marker. Okay, so if you see when it comes to the HPLC, HPLC is the high performance liquid chromatography technique. High performance liquid chromatography technique. So here, if you see this one, these are the common. There is a solvent reservoir. There is a HPLC pumps. Maybe those may be working in the industry. They might have touched this one. And there is a degasser, and then the solvent mixing depending on the 80-20 methanol water, acetonitrile water, acetonitrile. So depending on there is a different that we call it as the method development, and then we call it as the development of method for a particular pharmaceutical drug. So once this solvent is mixed, here you are going to inject your sample. This we call it as this part we call it as the mobile phase. Mobile phase means moving phase along with your compound. Then your solvent is pass through the pre-column or guard column. So what the pre-column or guard column will do, if any impurities are there, it purifies. Then your solvent is going to mix with your sample. Here you are going to inject your sample. So this sample and like mobile phase, then enter into the analytical column. So this analytical column, based on their physical and chemical, mainly physical properties, the compounds are going to be separated like a running competition only. Already I told now. Everybody has strength is different. For example, not all the entire we have party people have the unique properties. They may not reach the same time. So to the detector. So here the same principle compounds also. Every compound has their unique physical properties. So entire compounds are separated in the analytical column. So finally, detector will detect, or otherwise you can these compounds can enter into the mass spectrometers. Like same here also you required this is the HPLC, and here also you required a interface, because always HPLC it's a chromatographic technique. Always the chromatography works at the atmospheric pressure, and so MS always works at the high vacuum. Therefore, we require an interface. We have the various interfaces. Are there any particle beam interface and APCI interface, and maybe the ESI interface, and so different interfaces are there. So through that interface, then the molecules are entered into the ion source. Ion source, it makes the ions, and the mass analyzer, it separates the ions, detector detects the ions. And actually, for each topic is required 1 hour. Like for example, if you want to explain ESIMS, so ESIMS and ESIMS, the basic principle, and all the what are the interfaces, 5 interfaces, and the applications. So together maybe it may take 45 minutes to 1 hour. But anyhow, this is a basic idea about the LC coupled with the mass spectrometry. So then the various applications, particularly LCMS, pharmaceutical analysis, environmental monitoring, food and beverage industry, they have the application, clinical diagnostics, proteomics and metabolomics, and forensic science. So this various applications, random mass spectrometry, I will skip this part, and this required more than 1 hour to explain. So that I will show. These are the, if you see the tandem mass spectrometer, here how many mass analyzers are there, you see? So 2 mass analyzers. So one is the quadrupole, and this is the collision cell. Like another one is the another quadrupole. So like inside view of this mass spectrometer. So what it will do, what is the advantage of this tandem mass spectrometer? So what it will do, for example, so I want to analyze one compound. For example, let us take for example, I want to analyze human head. Okay. I required in the human head, I want to analyze about only left eye, not the right eye. So what the first mass analyzer will do, it separates the ions. First mass analyzer. For example, what I am interested only left eye, not the complete head. Head has fragmented. Various ions are there. One is nose, teeth, like hair, to ears. So what I am interested about only left eye. What the collision cell will do, so it makes then only will send the left eye to the collision cell. It makes the fragments. Then second mass analyzer, it separates the fragments and then it sends it to the detector. You see, all these fragments together, it belongs to the mass of the left eye. So this kind of technique, particularly this type of mass, and is specific. For example, particularly nowadays, the pharma industry has Nobody want to take the drug if it has the impurity. Nobody want to take a drug, it has the impurity. For example, that's why every drug, they have to show, like, majority of the pharmaceutical drugs are the chiral compound. In the chiral compound, one form only active. Make simple example, Maxo, everybody might have taken cetirizine tablet. Cetirizine tablet, yes. There are the two kinds of cetirizine, name one tablet. Then levocetirizine name is, yes, two tablets. Why levocetirizine? Why? There is a dextrolevocetirizine. When you are preparing some cetirizine tablet, maybe 50% of dextro compound is found, maybe 50% of levo compound. But actually, which is working against to the our, like, maybe human being, maybe levocetirizine. Yes. For example, if you see the price also, cetirizine tablet 2 rupees or 4 rupees ఉంటుంది, levocetirizine 8 or 10 rupees ఉంటుంది. ఎందుకు? Cetirizine has the mixture of dextro and levo. Levocetirizine has the pure form of the company don't want to lose 50% profit. That's why if they mix together, if they sell it as the cetirizine tablet, they have the dextrocetirizine and levocetirizine. Yes. And levocetirizine has this, so that kind of compound separation or that kind of compound we require this kind of tandem mass spectrometry. Okay, this is the now latest which is available in the industry. Triple quadrupole, 3 quadrupoles, 1, 2, 3, 3 mass analyzers, but one mass analyzer acting as a collision cell. But the instrument has the 3 quadrupoles, 1 quadrupole acting as the collision cell. This I will discuss. This is the 2 quadrupoles and ion trap. This maybe we'll discuss. This is a MALDI, I will not discuss. Yeah. So this is some video. If I have time, I will one time only MALDI will take the class, only MALDI topic. So these are the various applications, particularly mass spectrometry has so many clinical research, environmental, food analysis, forensic analysis, particularly when it comes to the forensic analysis of body fluids, hairs for drugs of abuse. Drugs of abuse, that's a case criminal, drug testing in the sports, doping test lo పట్టుబడ్డమని అంటారు కదా, ఏమన్నా స్టెరాయిడ్స్ కానీ తీసుకున్నా, so that we can analyze with the help of the MALDI of mass spectrometer. Analysis of body fluids and hairs for drugs of ఏమన్నా మనకి అప్పుడప్పుడు సినిమా హీరోలు వీళ్ళు డ్రగ్ దాంట్లో పట్టుబడ్డారు, వాళ్ళ జుట్టుని దీన్ని అనాలిసిస్ చేస్తారు. సో బాడీ ఫ్లూయిడ్స్ అంటే మన బ్లడ్ ప్లస్ లేదా మీకు ఫోరెన్సిక్ అనాలిసిస్ హెయిర్ తీసుకొని, సో డ్రగ్స్ ఆఫ్ అబ్యూస్, ఏమైనా బ్యాన్ డ్రగ్ తీసుకున్నారు, మత్తు పదార్థాలు అంటారు కదా, మాదక ద్రవ్యాలు. సో దిస్ అండ్ ఆల్సో డిటెక్షన్ ఆఫ్ హిడెన్ ఎక్స్ప్లోజివ్స్ ఇన్ ద అనాలిసిస్ ఆఫ్ యాక్సలరేట్స్ ఇన్ ద ఫైర్ డెబ్రిస్. ఫైర్ డెబ్రిస్ అంటే మంటలు వస్తున్నాయి అనుకున్నాము, ఏమన్నా యాక్సలరేట్స్ అంటే ఏమైనా మంటను ప్రేరేపిస్తుంటారు. మీకు అప్పుడప్పుడు మన రీసెంట్ గా లాస్ట్ టైము వైజాగ్ లో ఒకటి అయింది, in pharma industry. They are not able to stop the flame. So in that case, they use this technique to identify what are there. So this is authentication of regulatory products. And like manaki market lo available unta fruit juices, like Maggi is the one instance. Maggi is some compound is there, don't eat it, like this kind of things they do in the forensic. So this is when it comes to the research. Actually, this work I have done during Taiwan. Again, this work I have published in 2014. This actually we identified the pathogens. Pathogens and there's bacteria, microorganisms in the clinical sample. We have collected the sample from the different clinical specimens. We use some kind of nanoparticle approach. So iron oxide nanoparticle, we separated the bacteria with the help of the external magnetic field. The separated compounds we analyzed with the mass spectrometer. We use that time I used the MALDI of MS. This is the I told now some fingerprinting approach. This is a protein printing for that bacteria. So but normally, so if the 10 to the power of 8 CFU per ml, so we can detect the bacteria with directly. So, but with my method, I use the nanoparticle to separate. So I can detect the bacteria whose concentration is, you see, 10 to the power of 4, almost each zero 10 fold. So 8 to 4 means almost 10,000 fold. And if the concentration is that less, also we can detect it. So this we have published that time. This is also mass spectrometry. This values are there, na? These are the masses of the proteins, particularly E. coli bacteria proteins. So we call it as a fingerprinting approach because each bacteria has some kind of unique protein pattern. So from that you can detect that bacteria. This is one work research. And another work recently, I think we have published, my PhD students, we have published in some good journal, RSC Advances. We have used some kind of, what is that one? Dopamine drugs అంటారు కదా, డోపమైన్స్ ఏంది, అవి కూడా మత్తు పదార్థాలు, నిద్ర మాత్రలు అంటారుగా. యాక్చువల్గా మీరు పబ్స్కి వీటికి పోతున్నప్పుడు జనరల్గా వాటిలో మీకు సినిమాలో చూస్తూ ఉంటారు, కూల్ డ్రింక్లలో యాడ్ చేస్తారు ఒక ట్యాబ్లెట్. సో బెంజో డైజర్పామ్ డెరివేటివ్స్, అది ఒక జోల్పిడమ్ టాబ్లెట్ ఇస్ ద వన్ ఆఫ్ కైండ్ ఆఫ్ dopamine. Actually, my student, she has done she has added into the drug into the apple juice. The drug, apple juice lo add chesi, she used some kind of nanoparticle and separated it, and after that she had developed a method, and they have done the analysis with the help of she has done with the help of the LCMS, liquid chromatography, mass spectrometry. So, and this we call it as a date rape drug center. Date rape drug center. మనకి సినిమాలలో క్లబ్లలో వీటిలలో ఉంటాయి కదా, ఆ డ్రగ్ అందులో ట్యాప్ మన సినిమాలో చూస్తాం, మొత్తం వచ్చి ఇట్లా పడిపోతారు కదా చిన్నపిల్లలు కిడ్నాప్ కి. సో ఇవి కొనాలని డైరెక్ట్ ఇవ్వలేదమ్మా మాకు కూడా. మేము ఐ హావ్ రిటర్న్ ఏ లెటర్ టు ద డాక్టర్ రాస్తే ఆయన ప్రిస్క్రిప్షన్ మీద ఇచ్చింది డ్రగ్స్. మీరు అనవచ్చు మీకు ఎట్లా వచ్చినాయి సార్ మనము. సో దే డోంట్ సేల్ డైరెక్ట్లీ. ఇఫ్ యూ ఐ హ్యావ్ గివెన్ ఏ లెటర్ టు, బికాస్ ఐ వాంట్ టు డూ సమ్ కైండ్ ఆఫ్ రీసెర్చ్ ఇన్ దిస్ వన్, then written a letter and they have supplied these tablets. This is one kind of this is also same kind of drug, but olanzapine, but I use it different. But here the difference is the nanoparticles are the different. Here we use the polyethylene coated nanoparticles. Here we use the amide based nanoparticle. This is also we have published in the recent journal only in 25 only, American Chemical Society. Here we have used some kind of amide based nanoparticle. These are the amide is there na, like malic succinic anhydride. This is the novel here, but almost the drugs are the same, but the nanoparticles are the different. And this one is I received the patent for this work also. We got the German patent, and I used the GCMSMS and LCMSMS method for the detection of the D vitamin. D vitamin తెలుసా? నాకు తెలిసి మీరు చెక్ చేయించుకుంటే more than 50% D vitamin deficient. నాకు కూడా D vitamin deficiency. The majority of the people put two common tests doctor. One is vitamin B12, second is the D vitamin. So majority of the people has the D vitamin deficiency, but we have developed one method that is based on the GCMSMS. So the method which has the low cost, almost we can detect the D vitamin with the ultra low concentration and with the amount of only 50 rupees. So this one we have patented this method. Actually, we have compared with all the methods. This is a commercial method. Chemiluminescence, what the people are testing, and the accuracy is not much. And with the LCMS and MS and also amplifix dye-in reagent and GCMS. This is the best method. The best method is you can determine the D vitamin even it is in the 1.5 nanograms per ml. Anta takko concentration you can determine. And here also this is also the one of the best method, but here is the runtime is more. Here this is also runtime is less, but the cost wise this reagent is the more costly reagent. Amplifex dye reagent is little more this costly reagent. Then this one we have different methods we have compared, and I have the one project. This project is supported by Telangana government, Telangana State Council of Science and Technology, and along with the Taiwan government also. We have an international project. This is the patent I have received for German patent. He is my collaborator. He is the professor who is the project I am along with him. I have worked along that professor. I have the collaborative project with him. This is the one. These are my acknowledgements. First, I should acknowledge the Pramila madam and Koteshwara sir for inviting me. So these are the acknowledgement. He is my PhD boss. He is my postdoc boss, and he is my collaborator. Still, I have the projects with him. He is another Taiwan. These both are from Taiwan. And these are my postdoc lab mates, my PhD lab mates. These are good friends. These are my family friends. These are the Osman University, my colleagues who are recruited along with me. So 23 members. And I also acknowledge with, because he invited me several times. I have visited so many times Taiwan because of the project, and he is another colleague. And that is the mass spectrometry laboratory only. I worked almost more than my PhD time. 6.5 years I worked along with him, and these are my research scholars who has completed almost more than 10 members or 11 members completed. So these are all the scholars who have completed their pictures and those who, and because but each people has worked in the different area, and some are working in the, but majority are working in the government sector. Nobody is in the, but I am lucky because why I am lucky is my students are all at JRF. That is the advantage for me. That is the almost 10 members who have completed the PhD. These are the pictures of those things, and these are currently I have one project. These two are working with me, and she's from Kerala. Vanisri, he is from here only. These are the project students, and she has completed like GCMS work. She has completed. Right now, she is working with the NIPER National for NIPER Hazipur as a assistant professor, and remaining all are some degree college faculty. These are all. So these are we have conducted 2 times international conferences. All the Taiwan professors visited here, and some are like these are some PhD vivas and these pictures, because I should acknowledge them because I am presenting their work. Maybe somebody has done the work, but I'm just sitting and giving idea, but they have to execute. So that is these quotations always I will end. I like these 2 quotations. This slide and another slide is this last slide are the fixed for every talk. The thing is only add up. Maybe some new person will come. I will try to include that picture because I will take every student because when they are submitting the thesis, maybe you can see all the pictures with the thesis have. Everybody has. So we'll take the pictures, those who are submitting the PhD. And these 2 quotations which I like is the one by Swami Vivekananda, one by Abdul Kalam. So maybe this is for, I think this is suit for everyone. So wisdom lies not in the amount of the knowledge acquired, but in the degree of its application. మీకు ఎంత నాలెడ్జ్ అది కాదు. హౌ